Artifact 11 consists of Standard 6.2, its D criterion 20, Standard 6.3, its D criterion 21, and Standard 6.4, its D criterion 22. Standard 6.2, its D criterion 20, requires that I manage the use of technology for learning in a non-traditional classroom setting. On this slide, you can see examples of my students following the rules, guidelines, and parameters I set for a project using our school's makerspace as they attempt to make robotic instruments. Here, you can see examples of my students staying engaged as they work on the various parts of the project. We can see them wiring a breadboard, coding an Arduino, and testing their prototype. Standard 6.3, its D criterion 21, calls for the creation of opportunities for my students to use a design process and/or computational thinking. This slide shows the first two steps of the design process I used in the instruction and implementation of the Robotic Instruments project. First, to get my students to imagine what they could do with this project, I showed them a few videos of Shimon, a robotic musician created by Georgia Tech. I then created a prototype of some servo motors with an actuator that would then hit a drum or strike a key. I had my students create similar devices to actuate their found instruments from a previous project. Next, I had my students try their found instruments out with their devices. We shared these performances with our mechatronics students who provided us feedback, and then gave my students time to go back and modify their devices. I also included the computational thinking model into this project. For the abstraction, students had to diagnose how their found instruments produce sound. For the decomposition stage, the students had to identify the movements necessary for the instruments to produce that sound. For the pattern recognition stage, students matched the required movements of the instruments with different motors that could mimic those movements. After students made their prototypes, they tested and debugged their devices. For the creating algorithms, students created Arduino codes to actuate the servo motors for their devices. In the understanding systems stage, students were able to adjust their Arduino codes once they saw it in practice. And for creating computational models, the students created blueprints of how one could recreate their devices. Standard 6.4, its D criterion 22, states, model and nurture creativity. On this slide, you can see examples of opportunities for my learners to be creative with digital tools and technology. In the first example, the obvious method for removing rock candy from its dowel turned out not to be the fastest or cleanest method. In the second example, students learned that there were lots of different ways to wire their breadboards, but still get the same outcomes. And in the last example, the students found that there were lots of different ways they can code their Arduinos. Some were more effective than others. The students did get to showcase their projects for the mechatronics classes and receive feedback. Here is an example of one of the performances.